Okay, big news. Version 1.2.0 of Siril has come out of beta as of June 1st. We are now in release candidate 1. So I figure I'd take this opportunity to remake my beginner's processing video that I did for version 1.0.6 back in December to include some, but not all of the new features. This is still going to be a beginner's tutorial just to get somebody started who is interested in learning the software and how to process their data. I'm not going to get into all the new features. We will be using StarNet, which is one of the new features for this release. The older video still applies, but you had to kind of peck around and find where some things were moved. And so I just want to put a new one out there with this new version, so there's no guesswork involved. If you're interested in more of the new functions or even more of a deep dive into the functions I'm going to show you in this video, go back to my channel and browse through the videos I have. I have a lot of videos broken out into individual functions that do kind of a deep dive. So anyways, let's get to it. This is a little bit of a long video, but it's start to finish, so you'll end up with a nice image at the end. My name is Rich, and you're watching Deep Space Astro. Okay, we're going to start with the 3 pieces of software we're going to be using for this tutorial. The first and obvious is Siril itself. So Siril.org is where you want to go. Select your operating system, download it, and install it. It's really straightforward. I am running on Windows for this tutorial though. The second piece that we're going to need is StarNet, so we can remove the stars from the image. And the third and optional piece is Topaz DeNoise AI. At the towards the end of the video, I'll show you how to clean up some noise in your image using this. Again, it's optional. This is a paid program, so just be aware of that. I'm not going to show you how to install Siril, but I am going to go through the StarNet installation because it can be a little confusing for some people. So starnetastro.com, click on your download link up top here. And you want to scroll down to where you see command line tool. This is the one that you want to use. Don't download anything else that's up above here. These are the standalone applications that I showed in the first video. This version of Siril actually has StarNet functionality built into it. Therefore, it needs the command line version of StarNet. So again, I'm running on Windows. So I am going to click on the StarNet v2.CLI_win.zip. and save that to my downloads directory. And it's 177 meg, so depending on your internet speed, that'll take a couple minutes. We'll pause and come back when the download is done. Okay, StarNet has been downloaded. Here is the zip file in my downloads folder. I'm going to right click on it, select extract all, hit the extract button. And it'll just take a second. Once it's done, now we have a folder in our downloads directory called StarNet v2CLI. You don't have to move this from your downloads directory, but like I've mentioned in my other videos, my downloads directory is just that, and I go through and I delete things every once in a while. So I'm going to move this to a permanent location on my hard drive. So I am just going to hit the little cut button up top here. And I have a folder called Astrophotography. You can use any folder that you want, but Astrophotography is where I keep my stuff. And then hit the paste button, and it's moved the StarNet folder into the Astrophotography folder up top here. So with that in place, now we need to configure StarNet within Siril. I'm going to run Siril and come over to our little hamburger menu button up top here. Click on Preferences, come down to Miscellaneous, and then right here under software location where it says must point to a valid StarNet executable, you're just going to click on this box. And now we're going to browse over to our C drive, Astrophotography, StarNet v2 once more, and then just select the starnet++.exe file and then click open. Now you'll see you've just configured StarNet within Siril. Click your apply button, and you're done. Your StarNet installation configuration at this point is complete. So we're going to close Siril just for now. You don't have to, but I'm just trying to keep my desktop clean as I go through this stuff for everybody. And we don't need the browser open anymore. The first thing you need to do before you start using the script within Siril is organize your images in your calibration frames. And what I mean by that is the script looks specifically for these folder names. So it has to be biases, darks, flats, and lights. In your biases folder, those are all your biases frames. Same thing with your darks. Those are your dark frames, these are your flat frames, and these are our actual images that we took the night of the imaging session. As you can see up top, I have mine in Astrophotography, Nina, Crescent Nebula, which is what we're working with today. And then I have a folder called Process. Again, all of these folders, all these parent folders can be named whatever you want. The important part is you have these 4 folders named correctly. If you don't, the script will fail on you. So we're going to open Siril again now. And the first thing I want to show you as soon as it comes up here is you may have noticed when it ran that a command window kind of blipped up and minimized itself in the bottom. This is Siril's log console as it's loading. So this is just a log file when it launches. Shows you that it's loading the scripts that it found and registration methods and a sort. You don't want to close this. If you close this window, Siril will close along with it. So again, let's open up Siril. And the first thing that we need to do is set our working directory. And what I mean by working directory is the parent directory that these 4 folders exist in. So we're going to hit our little blue house button and we're going to come over and I'm going to go to my astrophotography folder. I have them in Nina, my Crescent Nebula, and then my process folder. So there's the 4 folders I was just showing you in File Explorer. Once you have that opened, hit the open button and you can verify your working directory path right up top here. You can see astrophotography, Nina, Crescent Nebula, process. Once that's done, you just come over to your scripts folder and click on OSC Preprocessing. Now, before I do this, a couple of things. These images were shot with a dedicated astrophotography camera. This entire process will work if you're using a DSLR or a mirrorless as well. So as long as you have all your images and your calibration frames organized in the folders that I showed you, the process is the same. So we're going to go ahead and click this. The second thing I want to talk about, when I start to run this, I'm going to stop it after a few seconds to show you an error that you're going to get over in the console screen as it starts running through its processing. So we'll go ahead and get that started. And the error that's going to come up is about creating symbolic links. And what symbolic links is simply like shortcuts to the file. And this is more around if you're using a dedicated astronomy camera and you already have your fit files that come out of the camera. Instead of the script making additional copies of it, it'll just make shortcuts to it. So it saves on hard drive space. Now, if you're running, I'm going to click stop here. If you're running raw files out of a Canon, like I've done before, well, those are raw files. They're not fit files. They need to be converted. So it's not really going to save you that much space anyways in doing this. But here's what I wanted to point out regardless. This line right here, you should enable a developer mode in order to create symbolic links instead of simply copying files. So again, this is optional. So if you have the hard drive space and you're not worried about multiple copies being made of your files, then you don't need to do this next step. 2 things for me. I don't like seeing this message and I do want to save on hard drive space. So what we got to do to take care of this is come down to our Windows menu and just start typing developer. And when you see developer settings, click on that. And right here is what the error message or the warning message was talking about, that you should enable developer mode. This is developer mode right here. You tick this on, you'll get a warning telling you that it's not safe, but you'll be fine. It's just a way to protect you from installing applications outside of the Microsoft Store. So click yes, developer mode is now on. We can close that. And now we'll go back to scripts and run our OSC preprocessing script. And that'll finish this time without that warning message for us. And again, if you're running from a dedicated astronomy camera, you're saving hard drive space as well. This will take a few minutes, depending on the processing power of your computer, number of files and such. So we'll let this go and come back when it's complete. Okay, the script has completed. As you can see down at the bottom here, it says registration stacking has completed. My total execution time was 3 minutes and 18 seconds. So the script has done its job and stacked the image for us. We're going to come over to our open button. It'll take us right into our working directory. You'll notice you have a couple additional folders created from the script. First is the masters, second is the process. You don't need to worry about those. What you're looking for is the result underscore with a number.fit. This number, you see the S at the end of it, is telling me total acquisition time was 31,680 seconds. So that comes out to 8.8 hours of acquisition time. Again, so this is the file we want to look at. You can either double click it or select it and click on open. And this is what you'll get. A black screen, nothing to worry about. You're still in what's called a linear state. And this is what Siril is going to help us do, is lift all those levels. All the data is there. We just need to bring them to the front so we can see them. So you will almost always see a black screen. Sometimes you'll see some really bright stars or bright areas of the object that you were shooting possibly, but regardless, most of the time it's just going to look like this, be completely black. to get a representation of the data that's in there, we can come down on the bottom. Like I said, we're in linear right now. And if I click my down arrow and select auto stretch, there we go. There's the data in our image. But again, this is linear, so you're not done. If you were to try to save this out as a JPEG, for example, and I'll show you guys how to do that later, your JPEG would look like this. So auto stretch is more or less a preview of the data that's there. We still need to work on this data set and apply what's called a stretch ourselves to the image. So go over the interface just a little bit. We are right now in our RGB tab. So we're seeing red, green, and blue channels combined. You can also look at just the blue channel, and just the green channel, and just the red channel. And one thing to note, new in this version, you used to always have to work on the red, green, and blue channel for some of these steps that I'm going to show you. That's no longer the case. You can remain on the RGB channel. So if you're familiar with the old version of Siril, where I covered in my last video that you could not crop or do a lot of work on the RGB channel, that's changed and you can in fact work in this tab now. So the first thing we want to do is we almost always are going to have cropping artifacts in our image. What I mean by that is all of the images that we took that night, as everything is aligned, we're going to have some artifacts along the edge. You can see it slightly on the bottom here in this image. Sometimes it's hard to see. Sometimes you can come over to one of the individual color channels and it'll be more prominent in one of these. But what I found I like to do is sit in the RGB channel, come out of auto stretch, and go into histogram. That usually lets you see your artifacts along the edge. And you can see them down here. You can see them along the bottom. I don't see too much on the top and sides. You know, it'll vary. It depends, again, on your data and the stacking process. So the first thing that we want to do is crop all those artifacts out. So we are just going to position our mouse in the top left corner, away from the top and the left edge. Hold the left mouse button down, and we're just going to drag a square over, paying attention to where we see our artifacts and stopping just short of those. Let go of the left mouse button. And we can make adjustments to this. If I hold my left mouse button down, I can move my whole selection around. And I can also click on the edges and move them in and out. So you can make a little bit more finer adjustments after your initial selection. Once you're happy with what you have, right click and hit crop. We've just now cropped out all the artifacts that are around the edge of this image. So we're going to go back to our auto stretch view, so it's a little bit easier on our eyes. And the first thing we want to do is what's called a background extraction. A background extraction will take care of any gradients that you have in your image. I don't have a lot of gradient going on in this one, but you do see it is a little bit lighter down in this corner and gets better as we go up towards the top left. So that's what background extraction will take care of for you. So the next thing to do is to come up to image processing, background extraction, slide this out of the way over here, and for the most part you can just use the default settings here, and we'll go through them a little bit. Smoothing, we're not going to change. Samples per line and grid tolerance, I will talk about. Samples per line right now is set to 20, which means it's going to put 20 samples on each line. Grid tolerance is how tolerant it is at placing those samples. So right now I'm just going to hit the generate button, and each one of these red squares are samples. So the samples per line, the 20, it will place no more than 20 samples left to right across the image. The grid tolerance set at 2, again, is how tolerant it is at placing those. If I was to, say, take that to 1 and then hit my generate button, watch my samples. As I hit the generate button, you can see some of them disappeared. If I go to 0.5, hit my generate button, even more disappeared. So it's a way to help you accurately select what is the background, because you do not want any of these samples on your object that you shot. Conversely, if you go the other way and hit generate, it's going to pretty much nail the whole image for you. So you can start with finding a good grid tolerance so you have less work to do. I'm going to stay at 2 just so I can show you guys how to clean this up. So like I said before, you don't want samples on the object that you're shooting. So all these little red samples we want to remove that are sitting on the Crescent Nebula. I'm going to do that just by right clicking and removing each and every one of them. A little bit quicker way of doing it, for example, if I kind of put my pointer around the area of these samples and I double click, it'll knock those out. And if I keep clicking, it'll keep stretching out further and further. We'll take these two out with right clicks. I like to clear off anything that's close to the edge. If you see any faint nebulosity, you'll want to take the samples off of that as well. Just go around, check everywhere that you have a background. If you see an area that the background where it was missed and there's no samples, left mouse button click, place a sample, just so you get nice, good coverage. Now, the other thing, and this can be time consuming, that you want to do is visually look at each and every one of your samples. It's real important that none of these samples are on a bright star. You don't want something like that. It's going to have an ill effect when it does its background extraction. So if you see anything on a bright or big star, right click it and remove off of it. Even ones like this is kind of a faint star. It's probably not that big of a deal, but I'm going to remove it anyways and just kind of move it down into a darker part of the sky. Same thing right here. It was sitting on that little cluster, it looked like. So, and these don't have to be lined up perfectly. We're just moving them around. These are sample points, right? They're not that specific. So just take a look and move your samples around. I'm going to knock the rest of these out, and then we'll continue on with the next step. Okay, I'm happy with my samples and where they're placed now, so I'm just going to come back over and hit the Compute Background button. And if you watch the image, it should smooth out the background for us, removing any gradients that we may have. If you're happy with that, hit the Apply button. If you still see some gradients going on, run back in, add some more samples, hit your Compute Background button again. This looks good to me, so I'm just going to hit Apply. So background extraction is now complete. The other thing that I wanted to mention with the background extraction is the Add Dither option. Now, I don't have the problem with this image, but there are times, and I think it's relatively specific to Canon cameras, where you can get some color banding. Again, I'm not using my Canon for this one. I'm using my dedicated astronomy camera, but this is what the banding looks like after you do background extraction. If you see something like this, then just come over and tick your Add Dither button and then click your Compute Background, and it'll clean things up for you. All right, so next step is to get the colors correct on the image. So we're going to come up to Image Processing, Color Calibration, and Photometric Color Calibration. And the first thing that I want to talk about are our coordinates, our rate ascension and declination. Since I was shooting with Nina and my dedicated astronomy camera, it stored the coordinates of the Crescent Nebula within the images. If you're using a DSLR or mirrorless, chances are these coordinates are all going to be zeros. If that's the case for you, all you need to do is to look up the catalog number for the object that you're shooting. In my case, it's NGC6888, and then click Find. It'll locate it. It'll give you sometimes multiple catalogs to choose from. It really doesn't matter if you do have 2 or 3 that are listed here, which one you select, as long as you do select one. And then your coordinates will be populated from that catalog entry. The second thing you need to be aware of is your focal length and your pixel size. Focal length is the focal length of your telescope or the lens on your camera in millimeters. I shot this with my Celestron 8-inch EdgeHD, which is 2032. The pixel size of my camera is 3.76. If you don't know the pixel size of your camera, then just do a quick Google search for it. So for example, I used to shoot with my Canon. If I shot with my Canon this time, I would just look up Canon M50 and pixel size. And generally the result will pop right up in the top of the page for you. So this is the pixel size for a Canon M50. My dedicated camera is actually 3.76, so I know that to be correct. And at this point, we would just click OK. Come back over to the console, and we can see that the photometric color calibration has succeeded. Click Close, and as always, we have an undo and redo button. So if I was to click the undo button and watch the image, you can see it goes back to the original before the color calibration, and then I can click redo to reapply that. Now, most of the time when you're shooting with a color camera, whether that's a DSLR or a mirrorless or a one-shot color astronomy camera like I did for this image, there'll be a little bit of a green tint possibly left in the image. Sometimes it's really prominent, other times it's not, but you want to remove it. There's really not any green in space outside of comets and as such, but in an image like this, we want to make sure we get that green cleaned up. So we're going to come up to Image Processing, remove green noise, and simply just click Apply. And it'll take that little cast of green off of the image for us. The next step I like to do, and you can actually skip this if you want, but I like to remove the stars from the image. And removing the stars allows you to work on the object that you shot, the nebula or the galaxy, without affecting the stars. So again, all we need to do, since we've already configured StarNet, is we're going to come up to Image Processing, Star Processing, and StarNet Removal. Now again, we are still in a linear state. If I came back down to my auto stretched and went linear, no stretching has occurred. StarNet requires just a small amount of stretching for it to work properly. So we'll go back to auto stretch, and because StarNet has that prereq, we're going to make sure we select pre-stretch linear image, and then also make sure that generate star mask is selected. Hit execute and sit back and give it a few minutes to finish. Again, depending on the speed of your computer, this can go slower or faster than what's going to happen for me. So we're going to let this finish and then we'll jump back in. Okay, StarNet has finished. As you can tell, it has removed every star from the image. That took a minute and 41 seconds to complete. We're still in our auto stretch mode, so we're still linear. So we're going to come down and we're going to go back into our linear mode, which will give us our black screen. You can see a little bit of the Crescent Nebula. That's due to the pre-stretch that StarNet applied. But now we're going to look at stretching this image. Up in image processing, you have three ways that you can stretch. We're going to be using the asign transformation along with the histogram transformation. The generalized hyperbolic stretch transformation, it's a little bit more involved. I don't think it's a good fit if you're just starting out with Siril for a beginner's tutorial. So we're not going to cover that one. I do have a video on how to use GHS. I'll leave a link up here in the corner if you guys are interested in that. But again, for now, we're just going to work with these two. So first, I'm going to jump into histogram transformation just to show you guys around a little bit. You'll be presented with this window here. And over on the left-hand side, even though you can barely see it, this is where all the data is at. That's why everything is black. If you come down to this little cog wheel for the auto stretch and you click that, it just stretched our image. Now you can do it this way and call your stretch done, and that's fine, but there's a better way of doing it. We can do better than this. And what I'm referring to specifically is if you look at my clip percentage here, for the shadows, it's at 0.3. You don't ever want that number. I try and keep it down below 0.1. 0.2 might be okay. 0.3 definitely is too high. What this is telling me, and you can see it in the histogram up here, is my darks are being clipped. That means I'm losing data in the shadows, and we don't want to lose data. So we're going to hit reset and close this, and we're going to come up to the assign transformation under image processing. We're going to click that one, slide this over, and we're just going to move our stretch factor bar over until we start seeing the nebula appear. And on this one, I have to do it pretty aggressively. Again, it depends on your data. You may get halfway, you may get, a third of the way and start seeing everything, but probably the best way to do it is just keep moving your slider until you start to see your nebula in the image. Don't have to worry about seeing all the detail. We're just trying to give this thing a kickstart so we're not clipping our blacks. So that looks good. I'm going to click apply, and then I'm going to come back up to image processing, histogram transformation again, and this time we're going to do this manually. So now you can see, because of that initial stretch that I just did, we can see our data. And up top here you can zoom. So if I hit my plus button, I can zoom in on my histogram so I can work with a little bit better. So I'm going to back that down just a little bit. This triangle over on the left is for your shadows, your darks. This one in the middle is your midtones. And this is the brightest part of your images. We always leave this one over on the right, so we're not going to touch that. But what I am going to do, let me bring my zoom back down. I'm going to take my midtone sliders and I'm going to bring it over towards the histogram. And you can see the effect it's having on the image. And this is just about preference, right? You don't want to go too much, right? Too bright, your background's starting to get too bright. You are getting, it's a balance, right? Watch the details, watch the nebula, but keep an eye on your background as well. But we're going to back that down a little bit. Just play back and forth. And then I'm going to grab my shadows because I have a little bit of room in here. Again, if I zoom in, I'm going to bring the shadows in closer to the left-hand side of the histogram. And you'll see that gets a little bit darker. So we'll go back to the midtones, slide that over. And I usually just, again, I'm watching the background as well. I don't want it to get too bright. But that looks about good. So once you have it where you're at, We have no clipping going on. Go ahead and hit apply and then hit the close button when that's finished. So now you can see we're in linear mode. This is an image that can be saved out. It's been stretched, the data has been pulled forward. Now, the next thing, if you want, you can play with your saturation levels a little bit. So if I come up to image processing, color saturation, I can increase or decrease the saturation of the colors in the image. Things to note is the hue menu. Global means all 3 channels at the same time. So if I drag this over to the right, you can see it's getting really red, because red is the prominent color in this. I can go to the left and start taking the color out if I want to. The background factor will actually protect the background. So if you're adding saturation and you're starting to see red in your background, you can go one way or the other to protect it, to remove that red and only focus on mostly the object within the image. So I'm going to hit reset on that and show you the other options. So that's global. Like I said, you have other color options here as well. So again, this is mostly hydrogen alpha, which is mostly red in the image. But if I wanted to just focus, say for example, on what's cyan, which there's some faint oxygen 3 gas around the edges of this Crescent Nebula, I could try to pull some of that out. It does get a little bit more of a blue tint to it as I do that. As you can see, I tapped it out. I'm all the way. Can't go anymore. But what I can do is hit apply and then image processing, color saturation again, and then go right back into it. And it'll give me more room to play with. Just got to be careful with it. You don't want to overdo it. Otherwise, the image will just look too blotched out. So just a way to do this. I'm going to come back in one more time, leave it on global, and just bump it up just a little bit, not too much, and hit apply again. Now, again, you can be done at this point. If you're happy with this, you can skip ahead in this video and go right to the section where it shows you how to recombine your stars back into your image. But this is part of my workflow. So I am going to take this into Photoshop. In order to do that, I am going to come over to this button up here in the top. This is Save the Current Image in a different name. Under Supported Image Files, I'm going to select TIFF. And I am just going to leave the file name the same. So this was a .fit file. All it's going to do is save it as a TIFF for me in my working directory. So click Save. You need to go 16-bit because the camera raw filter that I'm going to be using requires 16-bit in Photoshop. Click Save. And now let's go over to our working directory. Here is our TIFF file that we just saved out. And what I should have pointed out previously when we did when we ran StarNet to remove the stars, we ended up with 2 additional files. One is the starless file, which you can see right here. That's the image that we're looking at. And then it created a second one called Star Mask. This is actually our stars. This is stuff we used to have to do in Photoshop, and now it's all done within Siril. So again, with our TIFF file, I'm just going to double click it to open it up in Photoshop. And the first thing that I like to do when I come into Photoshop is come up to Image, Adjustments, and Levels. This is your histogram, right? So the left side is your darks, right sides are your brighter areas. You can see we have a space between the left side of the screen and where the actual data starts. So you can slide that over to close that gap up. I'll give you a little bit more contrast. Click OK. And then again, Image, Adjustments, Levels, and then I like to do the same thing and check each of the individual channels. So under Channel, click the pull down menu, start with your red. The red looks good. Green's got some movement that we can put in there. And you can see it's changing the background, the image, to more of a magenta color. But that also tells me that the blue channel needs an adjustment as well. So once we start moving that over, our colors will start coming back out to where we expect them to be. And then hit OK. So now our channels are nice and tight and lined up with each other. Next, I go up into Filter and Camera Raw Filter. And Basic is where I do most of the work. This just allows you to do a little bit more granular tweaking than what's available in Siril right now. These are pretty self-explanatory. Temperature, you can change the temperature, you know, go on the yellow side, on the bluer side. Any of these adjustments that you make, if you double click on the little head here, it'll reset it back to 0 for you. So if you mess something up, you don't have to worry about it. But you know, depending on what your image looks like and what you're trying to do with it, you can play with these, and it'll really make your image pop a little bit more. So exposure, you can bump your exposure up, not too much, obviously, not too far. You take it away. I'm not going to mess with the exposure. Same thing with the contrast. You can add a little bit more contrast into the image. I like to play with the highlights. You can see how the stuff around the edge is starting to glow a little bit more. My shadows. And just move them back and forth. Get an idea of what it's doing. We'll go to the whites. I'm going to leave the whites alone. The blacks. Let's bump those up a little bit. These three that right here, texture, clarity, and dehaze, they're pretty cool. You can get crazy with them. You can really overdo it, and everything will start looking really fake. But it'll also bring some more detail, it feels like to me, into the image. So again, play with them. Dehazing. If we go to the left, you're actually putting more of a haze into it, right? So if you have more of a washed out image, you might play with bring that over to the right. I don't use the dehaze too often, but clarity is usually the one that I go for. So if I slide this over to the right, if I go all the way, you can see what it's doing. It really, I mean, that's too much, but just to give you an idea, we go back this way and it softens it. So I like to bump it up just a little bit. Again, just watch the image, see where you like it. Same thing with texture. You can add some texture into it. I don't use this too much because it really gets crazy with it. Again, there's to the left, there's to the right, but we're going to leave that at 0. Just bump the clarity up a little bit. Click OK, and it just gives it a little bit more pop. Like I said, just a granular way of tweaking everything. The next thing that I like to do is run it through Topaz DeNoise. Again, it's a paid program. It's standalone, but it's also a plugin within Photoshop. So we'll go to Filter, Topaz Labs, and Topaz DeNoise. Again, this is an optional step. There's other ways of denoising, even within Siril now. I cover that in other videos as well, but again, this is a beginner's tutorial, so I don't want to get too crazy. So right now, there's basically 4 different settings I can use in denoise. It's on standard right now. That's the one it ran against. So this is the before, this is the after, and actually, if we go into a split view, then I can move this back and forth. We'll let it finish updating down here in the bottom. So again, on the left is before, on the right is after, and we can move the slider back and forth and see the noise that it's taking out. Like I said, different settings. Got to be careful. This program does a good job, but it's not really intended for astrophotography. So sometimes it can get it wrong. It's our clear. So I like the clear. I think that looks good. So we'll leave it on clear and just click apply. And it'll apply those changes, removing our noise for us and take us back into Photoshop. Okay, we're done with the starless image. Now we need to simply just save the TIFF file. So File and save. We're done with Photoshop, so I'm just going to close that. Now we're going to come back into Siril and we're going to add the stars back in. What you have to keep in mind is when we save this out as a TIFF file, we saved it as a 16-bit file. We need to open that TIFF file and save it back as a 32-bit fit file in order for the recombination of the stars to work properly. So we're going to click on open. We're going to find our TIFF file in our working directory that we just modified in Photoshop. Open that up. You can see up in the top right here, we have our TIFF file opened. We're going to come back to our save button, and I'm just going to look for our original fit file that StarNet created for us right there. So it's the same name as our TIFF, but it has a .fit extension, just to keep things simple. So I'm going to double click that to open it up. It's going to ask me to replace it. I'm going to say yes. And this is where I was saying you have to make sure you go back to 32-bit. So select 32-bit and then save. So now we are looking at our starless result.fit file. Time to put the stars back in. So image processing, star processing, star recomposition. Don't let these settings scare you. We're not going to go through this right now. This is more of an intermediate advanced function of the tool. So all we're going to do is load in the 2 images. So even though we see our starless image right here, we need to tell the star recomposition tool what that starless image is. So right here where it says none under background stretch parameters, we're just going to click it. We're going to open up our fit file, the same one that we have opened up here. You'll see the screen blank and then come back in with our image. And then over here on the star stretch parameters, we're going to click on the area that says none, and we're going to find that star mask file. And we're going to double click and open that. All I want you to do right now is just play with the stretch factor on the star stretch parameter side. There's other ways of doing this, better ways of doing this, but again, this gets into the generalized hyperbolic stretch stuff, which I have covered in another video if you're interested. But for a beginner's tutorial, we're just going to keep it simple. So we're just going to take our stretch and we're going to watch the screen over here and move it a little bit at a time until we start seeing our stars. Every little bit of the movement that we bring in, we can see those stars are coming back. And what's nice about doing it this way is I can come all the way over to the right, and that brings back my star mask as it was in the original image. I like to tame the stars down, so I only bring them over about, maybe 70-75%. But however you like to do it, just keep moving it back and forth until your stars come back. Once you're happy with it, click the apply button under the star stretch parameters and you're done. Click close, and there's our final image. You can see up top here it says unsaved star recomposition result. It means just that. This has not been saved yet. So again, come over to your save button. I like to first save it as a fit file, so we'll just call this NGC6888, and we'll just say dash final, spell it right. So I'll have a completed fit file to work with. Leave it as 32-bit and hit save. So now up here, you can see we have saved our file. Now you want to share this on social media someplace. Again, you can come to your save button, supported image files. You can do PNG, JPEG, BMP, whichever you like. I usually do JPEG. You can give it a file name or you can leave it the same. You can see it just changed the file extension, which is good enough for me. Hit save, leave the quality at 100%, hit save again. Now if we go back to File Explorer, there's our JPEG. I can just right click and we'll just open it up in Photos real quick. So there's our final image that can be posted on social media. Okay, so there you have it. The new beginner's tutorial start to finish for version 1.2.0. Hopefully it stays valid for a while. I think that it will. If they add new features and functions, then I'll figure out a way to let you guys know about it. Probably just separate little side videos like I've been doing with the other functions that they came out with. Hope you enjoyed the video. I hope it's helpful. If you're not a subscriber, please consider subscribing. Give the video a like. I want to say thanks to all my members that join my YouTube membership program, as well as the membership program at buymeacoffee.com. If you want to see your name in the videos and become a member yourself, the links are in the description below, or hit the join button right below the video. Once again, I appreciate everybody's time. We'll see you on the next video, and clear skies.